Good morning, children. Today, I'm going to teach you all about circles. So, here the chapter is chapter number 18, and it's about angle and cyclic properties of a circle. Angle and cyclic properties of a circle. Okay, so first we are going to deal with angle properties of a circle. As we know, in a circle, okay, any lines can be drawn, the chords can be drawn, and those chords make angles anywhere on the circumference. Okay, let us suppose the chords meet at these points on the circumference and angles are formed over here. Likewise, if you draw another chord touching the other chord, so here one more angle is formed. So there are 4 angles I've drawn, okay, which have been formed in the circle. So we are going to deal with these types of questions here. So that is angle properties of a circle. Okay, so what properties do they have whenever angles have been formed in a circle? So now we go to the theorem. The first theorem says that angle subtended at the center is double angle at the circumference. So angle subtended at the center is double angle at the circumference. Okay, what that means is, if an angle is formed at the center by any 2 lines, this is the center of the circle, an angle is formed over here. Let us suppose an angle is formed over here. Okay, let's name this as reflex angle AOB. Okay, now if any other angle has been formed at the circumference also, one angle is formed at the center, another angle is formed at the circumference. Now according to this theorem, angle subtended at the center, the angle which is formed at the center, will always be double of angle at the circumference. If this angle, let us suppose, is 30 degree, the angle formed here will be double of 30 degree. That means it will be 60 degree. Okay, any angle formed at the circumference, angle at the center will be double of that. That's the first theorem. Okay, now converse of theorem 1, we can write angle at the circumference is equal to half angle at the center. Angle at the circumference will be equal to half of angle at the center. Angle is formed over here. Same thing. Okay, let me draw another thing. Okay, one angle formed over here. Same thing, just the converse of the previous theorem. Angle at the circumference will be half of angle at the center. This will be half of this angle. Okay, the other one, theorem number 3, you can write angles at the same segment are equal. Angles at the same segment are equal. Means to say, angles at the same segment. Suppose this is a circle. One angle is formed here. Okay, one angle is formed here with the help of these 2 lines, and another angle is formed here. We can say that these 2 angles are formed at the same segment. This is the segment of the circle, a small part of the circle. Okay, so one angle is formed here, another angle is formed here. These 2 angles are at the same segment. Okay, these 2 will always be equal to each other. That's the third theorem. Here again we can say these 2 other angles are also equal to each other now. So angles at the same segment are equal. Clear? The other theorem is, okay, angle in a semicircle is always equal to 90 degree or right angle or 90 degrees. So if an angle is formed in a semicircle, so this is a circle, let's draw a diameter which is passing through the center. An angle is formed in a semicircle. It may be formed at any of these parts of the circumference, okay, at any of the segment. So if it is formed here, then also it will be 90 degree, or if it is formed here, it will also be 90 degree. Rather, we write 90 degree, indicate 90 degree with a box. Okay, so because why 90 degree is formed over here, under what condition 90 degree will be formed, is that the line has to pass through the center and the angle has to be formed in a semicircle. In a semicircle, half part of the circle, it will always be 90 degrees. Okay, so if I draw a line here also a 90 degree will be formed. So these are the theorems that we need to know before solving the angle. We'll do the cyclic properties after some time, okay? And the other one that you can say is angle of the opposite angles of a cyclic quadrilateral will be equal to supplementary. Okay, now the next theorem that says is the sum of opposite angles of a cyclic quadrilateral is supplementary. Sum of opposite angles of a cyclic quadrilateral is supplementary. Okay, now what that means is a cyclic quadrilateral. Let's understand what a cyclic quadrilateral is. Quadrilateral means a four-sided figure. In order to be cyclic quadrilateral, the 4 points or the 4 vertices of that quadrilateral has to touch the circumference. Then it becomes a cyclic quadrilateral. So let us suppose if I draw a quadrilateral, the vertices of which touch the circumference. Let us suppose A, B, C, D. This becomes a cyclic quadrilateral because all the 4 vertices touch the circumference. This is a cyclic quadrilateral. If I draw a quadrilateral where all the 4 points do not touch, okay, let's draw like this, okay, there are also 4 points, okay, but all the 4 vertices do not touch the circle or the circumference. One point is somewhere near the center, so this is not a cyclic quadrilateral. Okay, so the opposite angles of a cyclic quadrilateral is supplementary, means if 4 vertices are there. Now if you take one vertex over here, one vertex over here, these are the opposite vertices of a cyclic quadrilateral. Always this plus this, the angles will be equal to, the sum of these two angles will be equal to supplementary, means 180 degrees. Okay, as well as this angle and this angle, the sum of these two angles will also be 180 degrees. So this is the other theorem that we need to know in order to solve the problems regarding angle properties of a circle. Okay, then let's start with the exercises. The first example, let me do. In the given figure, okay, let's say, let me write the question. In the given figure, angle BAD is equal to 65 degrees. Angle ABD, okay, let me write the other place, I don't know. Angle ABD ABD is equal to 70 degrees and angle BDC is equal to 45 degrees. Okay, these are given to us. Find angle ACB. Okay, we need to find angle ACB. Now, the first question, okay, let's see. There are two things asked over here. First, let's prove. Let's prove this first. That AC is the diameter. Is the diameter of the circle. Okay, let's take this circle. It's given ABCD. ACD, something like this, Here 45 degrees. ABCD. Okay, ABCD. Then here 65 degrees. The whole value is 65 degrees. And this is 70 degrees. This much is 70 degrees. Okay. Look here now. In the given figure, angle BAD is given 65 degrees. BAD, this value, BAD, this value is 65 degrees. Angle ABD is 70 degrees. ABD is 70 degrees. And angle BDC is equal to 45 degrees. BDC is equal to 45 degrees. These things are given to us. Now, with the help of the given values, we need to prove AC is the diameter. So we need to prove AC is the diameter of the circle. Let us suppose AC is the diameter. Okay. In order to be the diameter of a circle, as we told just now, suppose this is the diameter of the circle, any angle formed on one part of the circumference must be 90 degrees. That means we said the theorem says angle formed in a semicircle is 90 degrees, is equal to 90 degrees, is a right angle. Okay, so if this has to be a diameter, the angle formed here should be 90 degree equal to 90 degrees. Okay, 90 degree angle. That means if this is the diameter, then we can say that the angle formed over here means ADC. This whole value has to be 90 degrees. Then we can prove that, okay, AC is the diameter of the circle. Now, out of that angle ADC, small part, the other part, 45 degree, has been given to us already. So what our work will be is just to prove angle ADB should be equal to 45 degrees. Okay, if you can prove this angle is equal to 45 degrees, then obviously we can say that will come as 90 degrees. Then it is proved that it is the line AC is the diameter. Okay, now solution. We are doing the first part. Okay, in triangle, we'll take triangle ADB. Okay, in triangle ADB, what things are given? Angle DAB is equal to 65 degrees, that's given. Angle ABD is equal to 70 degrees, that's also given. Now we need to know angle ADB is how much. Okay, so we'll take angle DAB plus angle ABD plus angle ADB is equal to 180 degrees. Look here. ADB, sorry, first let's take DAB. DAB, first angle. ABD, second angle. And ADB, third angle. This angle plus this angle, this should be equal to 180 degrees, because sum of angles of a triangle is always equal to supplementary. Okay, because sum of angles of a triangle is supplementary. We know that. Yes. Supplementary. And it's important that we need to write the reasons after writing the statements. Okay, why do you say that this plus this is equal to 180 degrees? Because always we know in one triangle, if you add the three angles, the sum of angles in a triangle will always be equal to 180 degrees. That is supplementary. Okay, let's put the values now. 65 degrees plus 70 degrees plus angle ADB is equal to 180 degrees. 135 degrees plus angle ADB is equal to 180 degrees. Angle ADB is equal to 180 degrees minus 135 degrees. Therefore, angle ADB is equal to 45 degrees. We got that now. Okay, we found that this angle is equal to 45 degrees. Okay, now again angle ADC, now we are taking the bigger angle ADC. Okay, ADC, the big angle, is equal to angle ADB plus angle BDC. ADB, that means smaller angle and the other smaller angle BDC. This big angle ADC is formed of two small angles. One is ADB and the other is BDC. So if you add this and this, we get the bigger angle. Okay, so that gives us, we know already, we got this now, ADB as 45 degrees, BDC is also given to us as 45 degrees. Therefore, angle ADC is equal to 90 degrees. ADC is equal to 90 degrees. Okay, now according to the theorem what we learned just now, angle formed in a semicircle is equal to 90 degrees, we said. Okay, is a right angle. That means if it is formed in a semicircle, that means this is the diameter of the circle, because from the diameter only the circle can be divided into two halves. This diameter divides the circle into two halves. That means this forms one semicircle, this forms one semicircle. And we said in the theorem, angle formed in a semicircle is equal to 90 degrees. So the converse of the theorem, what could have been said is, if an angle formed at a circumference is 90 degrees, then the line is a diameter, isn't it? If 90 degrees formed here, means to say that it is a diameter. So we got this angle as 90 degree. Hence AC is the diameter of the circle. So we proved that this is 90 degree, means 90 degree if it is formed means this is the diameter. Okay, because angle formed in a semicircle is always equal to diameter. Angle formed in a semicircle is always equal to 90 degree. That means the diameter is making 90 degree. Diameter divides the circle into two halves. Okay. The other thing that is to be found, this first part is proved. The other thing that is to be found is ACB, angle ACB now. Number 2, angle ACB. Now look here, ACB somewhere over here, okay, here and here. Now in the previous theorem, again what we said, angles at the same segment. This is formed at one segment, this is formed at one segment. So these are formed at alternate segments. So angle ADB is equal to angle ACB is equal to 45 degrees. So the reason what you can write is angles formed in the same segment. Now if the angles are formed at the same segment, then they will be equal. At the same segment they will be equal angles. So we can say that this smaller angle will also be equal to this smaller angle. They are also at the same segment. This angle will be equal to this angle. Okay, so these are the ways with the help of the theorem which we can find the values of angles. Okay, let's do the other one now. Okay. Okay, if you have questions like this, in the given figure, O is the center of the circle. That is the question that had come in ICSE 2005. Okay. In the given figure, O is the center of the circle and AOC is equal to 160 degrees. Okay, let's suppose this is the circle and AOC. O is the center, A is here, C is here. Okay. Here it's given Y, small y, and here it's given, okay, something like this. X, here is B, D. Okay, A, B, C, D. These are the vertices of the quadrilateral. Okay, so it forms a cyclic quadrilateral, and the vertex from A, the line comes to meet at O, and from the vertex C, the line comes to meet at the center O. And what is given? Angle AOC is equal to 160 degrees. This is given 160 degrees. What is to be proved is, prove angle 3 angle Y, prove 3 angle Y minus 2 angle X is equal to 140 degrees. Okay, this is to be proved. If it's not clear, I'll write once again. Prove 3 angle Y plus 2 angle X is equal to 140 degrees. This is to be proved. 3 angle Y minus, sorry, it's given as minus 2 angle X is equal to 140 degrees. Okay, this had come in the ICSE 2005. That means to say, if we can find the values of Y and X, we can easily prove. Okay, our work is to find the value of X and Y. Now, in order to find the value of X, let's concentrate on the point X, that is formed, the angle that is formed by the lines AB and BC. Okay, ABC, angle ABC is also termed as X over here. Okay, now let's go back to the theorem once again. Angle is formed at the circumference, one angle is formed at the center. We know that. Okay, angle formed at the circumference is equal to half of angle at the center. We know that. The first theorem says. So what you can write is, angle ABC is equal to half angle AOC. Okay, this angle will be half of angle AOC. The reason we can write angle formed at the circumference is equal to half angle at the center. Okay, so angle at the circumference will be half of angle at the center, or ABC, instead of ABC we can write X, yes, is equal to half angle AOC is 160 degrees. Okay, so cancel this out, give us, therefore X is equal to 80 degrees. We found the value of X, right? X is 80 degrees. Now, likewise, we are going to find Y. Okay. Now, in order to find Y, what we can take is sum of opposite angles of a cyclic quadrilateral is supplementary. That theorem we can take now. Let's forget about this for some time. Let's forget about this. Okay, let us suppose it's not there. Okay, then we can see one angle is formed here, one angle is formed here. These are the opposite angles of a cyclic quadrilateral. So we can write angle ADC plus angle ABC is equal to 180 degrees. So reason is, it's important that you write the reason. Okay, it's very important that you write the reason. It's sum of opposite angles of a cyclic quadrilateral is supplementary. Okay, so we have the theorem. According to the theorem, it says sum of opposite angles. These are the opposite angles of a cyclic quadrilateral. The opposite angles will always be equal to 180 degrees or supplementary. So we got x, so we can write as x plus y is equal to 180 degrees because we already got the value of x as 80 degrees. So we can put this value 180 degrees. Y is equal to 180 degrees minus 80 degrees. Therefore, y is equal to 100 degrees. Yes, we got both the values of x as well as y. X, we got it as 80 degrees and y is equal to 100 degrees. Okay, substituting the value of x, we got the value of y as 100 degrees. Now, the final thing that is to be done, 3 angle y. So it's to be proved 3 angle y minus 2 angle x. So 3 into, we got 100 degrees minus 2 into x value, we got 80 degrees. Okay, just substituting the values of x and y in the given value, in the given equation. So this will give us 300 minus 160 will give us 140 degrees. So that was required to be proved. So that has to be proved as 140 degrees. That has been given in the question. Yes. So after putting the values of y and x, okay, substituting the value of y as 100 and the value of x as 80 degrees, after solving, we got 140 degrees. That was required to be proved. Okay, here it says prove that angle 3 angle y minus 2 angle x is equal to 140 degree. Okay, that was the ICSE question from 2005. Okay, this has been proved. So we can write hence proved. Okay. Okay, this is it for today, children, on circles. And please do practice exercise 18. Questions 1 have been done. Okay, 1, 2, 3, 4, 5, whatever you can. Okay, if in case you don't know anything or not understood anything, let me know. Thank you very much.